Good afternoon, everyone. Hi. Do I have to talk into this?
It's the only mic close by. So
Okay.
not so close.
I'm not comfortable staying in one position, but bear with me. And if I look away, you can't hear me anymore. I work at the University of South Wales as a lecturer in fire engineering, but I'm also a consultant fire engineer in the UK. And people come to me with their problems occasionally. And this one fire risk assessor came to me with a problem. And this is the story of that problem, really. What we're going to look at is the guidance that we have for staircases, sizing staircases to make sure they're large enough to get everyone out of the building quickly enough. And we did a drill, and we got some results from that. I'll tell you about that. And then we used Pathfinder to explore it a little bit deeper, what was going on, and to think about whether we had a problem or not. So you'll get the gist of it as we go along. Oh, here we are. How do I do this?
Here, I'll hand you this so you can talk if you like.
Okay, thanks.
Here, go ahead.
Is this on?
It is.
Hello. Right. Yeah. So this is not the most exciting video in the world, and I made it myself. It lasts 2.5 minutes. 2.5 minutes is the time that we allow in the UK. It's sort of in all the guides. It's the evacuation time that we how are we going? All right. That we accept. So it starts at not at ignition. It would start when the alarm is raised or when the fire cue is received, and it ends hopefully when the last person, it's ASET basically. It's when we want the last person out, the last time that we want, the last moment that we want the last person out away to a place of safety. So on a floor in a building, say, or let's say it's this room, we would want the last person out of this room in 2.5 minutes. That would be our criteria. How are we doing? Not even a minute yet. That's 30 seconds, one that. We vary the 2.5 minutes sometimes. In ADB, that some people have talked about sometimes, and it's our standard guidance in the UK. It's within all the figures that we use for sizing doorways and staircases is this 2.5 minutes. In this room, we'd give a bit of allowance. It doesn't say it in ADB, but in some of our other guidance, we'd have an allowance for the headroom, possibly for the lack of combustibles and that there are. The surfaces aren't very ignitable. I don't know. I wouldn't have thought so. But how do I stop this when I want to stop it? Hit next on that. Okay, thanks. Oh. It's just too exciting in the end. I don't. Okay. Anyway, eventually it ends. So 2.5 minutes is what our standard ASET that we use for general rooms. So our set, the time that we want people to be out, is of course less than that. I'm going to go on. It's just. I'm just going on. Now, when we size staircases, we size them as maybe some of you do, maybe all of you. Not just on the flow rate, but also on the capacity of the stairs to hold people. So our objective is not to get everyone out the building and downstairs and out in 2.5 minutes. Our objective is to clear the risk area within 2.5 minutes. And if they're in the staircase for another 10 minutes, then so be it. And disabled people, in rather tall buildings, we'd expect them to be in the staircase for quite a long time. That's not a problem. They're in a place of safety. So we size our staircases on these two things, the capacity to hold people and the flow rate. And as I've said, it's when that last person steps through the door, closes the door behind him, they've all bought themselves at least half an hour's at least half an hour's safety. Now, this whole story started with a building in London that a friend of mine inspected, and this is the building. 2 staircases. It was an office building. 88 people on average per floor. We have this, I'm not sure if you all use the same convention that we have in the UK. The ground floor is the one that's at ground level, and then the floors are numbered after that, going up the building, first, second, and so on. We had an average of 88 people per floor, more or less, apart from the third floor that had about 40 people on it. That's an anomaly that doesn't really matter. But anyway, the guide said, we have two guides that we use really in the UK, ADB and BS 9999, British Standard. And 9999 is sort of less onerous for some reason. And it said that there should be 427 people as a maximum on the upper floors 1 to 6. So this guy inspected the building, there's 480 people there, which is 53 people too many. It's multi-occupied, so lots of different occupiers in there. And he just came to me and he said, what shall I do? There's too many people in the building. Have I got to tell them all to lose 9 people, say? Which would bring it down to 427-ish people. And I thought, well, that's going to be a difficult thing to do. So I thought, let's do a drill, and we'll have people with stopwatches on each floor, and they can time how long it takes for everyone to leave the floor, to get into a place of safety. And if it's around, we're looking for 2.5 minutes. We don't know if that's exactly the safe limit. You know, if it takes 3 minutes to clear all the floors, then we're okay. So, and we can just accept it. It's outside the guidance, but we'll accept it. It's only 10% or so over. So that's what they did. They did a drill. I didn't go and see it, but I got the results, and I got. That's it. Those are ADB. We'll come to the results in a second. I'll just keep you waiting to build up the suspense. ADB and BS 9999. The ADB has been with us for forever, really. So it's published by, well, it's not published by the government, but it's approved by Her Majesty's government. And the British Standard is equivalent, and they're both sort of documents that are guidance, but if you follow them, you're deemed to satisfy the legislative requirements. Now, in this building, just out of interest, like I said, 9999 would have accepted 427 people. ADB would only allow up to 350 people on the upper floors. That's just the way it is. We'll come back to that maybe. One more thing, when we did the drill, we wanted to take out the factor of pre-movement time, because that's kind of, as a lot of you will know, rather difficult to predict. So, and it can be managed by good fire safety management in a building. We can almost eliminate these pre-movement times, the recognition time and response time, as I've broadly categorized the elements of that here. And we can manage them down to 0 by just training the staff and telling them, when you hear the fire alarm, stop what you're doing and get out. So we told them, and on this day, on the day of the drill, I told them to brief everyone in the building, let them know there's going to be a fire drill, and tell them when it goes off, just stop whatever you're doing. It's going to be at 11 o'clock. When it goes, get out. So we virtually wiped out this imponderable pre-movement time. So we're just looking at the capability of the building for evacuating people, how long it takes for people to get out, physically get out of the building, without trampling all over each other. So that's what we did. Now, also, our guidance documents, what they say is that in this building, which is allowed for buildings up to 18 metres, and any with a top story not more than 18 metres high, they don't have to lobby the staircases. They don't have to have two-door protection to the staircases. And this building only had single-door protection to the staircases, as I've sort of diagrammatically shown here. And when we do that, we have to say, well, we're not quite sure if we're going to lose one of the staircases, because there's only a single door. Let's put the safety factor in that we possibly might lose the whole staircase, because of this scenario here that I've tried to depict. Fire there, and someone's left the door open, it's off its hinges or something, the fire's getting into the staircase, we've lost it, everyone has to go down the other staircase. So that was the basis for the drill that we observed. We assumed that this had happened, and it's also the basis of the modelling that we did subsequently. That is a picture of the modelling we did subsequently. We'll come back to that. As you can see in the model, we've got the staircase gone. And there are the times at last. So we were looking for 2.5 minutes, remember? Well, not a million miles away. Not great. Only 40 people on that floor, so they did all right. And then we get to disastrous times down here. We just didn't expect such long evacuation times, and entirely down to people queuing at the doors to get out. There's 88 people, they can't get into the staircase. There's no reason to suspect that this wouldn't be replicated if we did it many, many times. We'd have slightly different times, we know that, but something of this order is what we would expect. We can't think of any reason why we shouldn't expect it. So the guy said, what do we do now? So the building we sorted out. We sorted out the building. We lobbied the staircases, basically. We made them put in two-door protection to the stairs. When they've got two-door protection to the staircases, they can use both the staircases. So these times dropped significantly. And it's all fine with that building. But that's not the end of the story, because this building was only 53 people over-occupied. And we thought, well, if we took 9 people out per floor, are we going to see all these times drop to around about 2.5 minutes? Well, of course we're not. I mean, you can tell we're not. So this is where Pathfinder came in. I thought, let's use Pathfinder to explore this. So we did the remedial works in that building, that's it. So if the building had been code compliant, this was the question, if the building had been code compliant, what would the evacuation times have been? So we built the model I built the model in Pathfinder. This is showing the ground floor and all the other floors, 2 staircases, and the building populated with the appropriate number of people. Now, first of all, I had to make sure that Pathfinder was giving me an accurate prediction for the building. So I modeled it with 480 people in, and I reproduced. I took away the staircase on the right. I reproduced the drill in Pathfinder. What I found was that whereas we had the big, you saw we had the big long evacuation times up at the top floor, Pathfinder by default, we had long evacuation times on the first and second floors, on the lower floors. And I figured that was because where the flows merge, where people leave the floor and enter the staircase, the people in the staircase were more dominant on the flow, taking command of the flow rather than the people in the staircase. Whereas what we found in reality was the people leaving the staircases tended to take priority over the people in the staircase. So the queues would build up the stairs instead of on the floors. And that's why we got the queues in Pathfinder when I just left it as it was, sort of raw, got the queues on the lower floors. So I had to tweak it. What I had to do was all these people down here, I had to give them more priority, which you can do in Pathfinder, but not all of them. That was too much. I had to tweak it a bit, fiddle about with it. And what I found was that I could fiddle about with that, and then I could move the people around, and I'd get entirely different results. So I had to do lots of runs. I did, I don't know, not a huge number. I was only doing this out of curiosity, really, to be honest. But I did a number of runs, about 10 runs, and with the priorities adjusted, and I would tweak the priorities until I replicated the actual evacuation times that we got for each floor. So each floor in the model was taking the correct, on average, the correct length of time to do it. So that was I managed to get Pathfinder so it was accurately replicating what we know happened in reality. So then I wanted to take 53 people out of the building. So I did that. I took 53 people out of the building, proportionately through the building, and in proportions with the priorities that I tweaked. And so now I had a code-compliant building in Pathfinder, and I was pretty confident that when I ran it, it would show me what would happen if we had a code-compliant building in the real world. And I haven't got to go out and do drills with real people. I can do it all in Pathfinder. So that's what I did. Right, another video. Hit something? The mouse?
Yeah, on the touchpad.
Oh, yeah. Okay, I can do that. I can do that.
And then you can make it big.
Yeah, I'll make it big. That's as big as it goes. All right, there we are. So they're all, now the ground floor, they've got their own, they don't come into it, the ground floor, they've got their own exits. There's exits at the back as well. They all left by their own exits. So it's purely the people on the upper floors. We're talking, look, little earthquake there, could have been in New Zealand. Purely that's me, just adjusting the view. Purely the people on the upper floors we're interested in. And this is what happened. I'll speed it up in a minute because it gets a bit boring. But again, it takes ages. There we go. That's just me speeding it up, okay? But they're all, they're all having to go down one staircase. This is what we expect to happen. Now, if there was a fire at the top there at this time, it wouldn't be great, would it? It wouldn't be great. That's enough of that. Bear with me. Okay, so there's the population reduced to be compliant with British Standard 9999, okay? No one would bat an eyelid if this building were built and populated with that number of people, and yet that's the sort of evacuation times that we can expect that Pathfinder revealed. So nearly 7 minutes on the top floor, worse than before for some reason. I did average these are the averages. Again, I did lots of runs because it's so susceptible to slight changes. It gives such varied results that I had to run it lots of times. I just relocated all the population of the building, of the population within the building, and ran it again and averaged the times. Is there a problem with this? Well, there appears to be a problem. In my mind, there appears to be a problem that we've got an objective of getting everyone out to a place of relative safety within 2.5 minutes, and yet this is demonstrating that it's going to take 6 minutes or 7 minutes to do it. And yet, that bottom line there, we have no history of fire deaths in offices in the UK. This isn't a new thing that I've discovered. I'm just looking at it differently. So why is there no history of fire deaths when obviously it can take 6 or 7 minutes to empty a floor where there might be a fire? Well, I've focused on 2 possible reasons. So we were using 9999 there. I was using 9999 as the guidance to follow. And this is new code. When I flashed up the picture of it just now, you might have seen, you wouldn't have seen, but it had 2008 on it. We've only been using it since 2008. Whereas ADB we've been using forever. So actually all the existing buildings that we have in the UK are actually built to ADB, and they're not built to 9999. So maybe 9999 is a problem. Now, no one quite knows. The committee that wrote it are quite secretive. Well, they're not secretive, but they just haven't come forward in telling us figures of how they arrived at the staircase sizes and the exit sizes. Maybe it's a problem, and we won't know that maybe for a few decades until we've had a few fires. Anyway, so I did, I modeled it, I put the population down to 350, which would be ADB compliant. And I saw what the evacuation times were there. And we're still, I mean, it's better with only 350, but we're still nearly up to 5 minutes for the top floor. So it would appear that, and this code we've been following for decades, and there is no problem. So why isn't there a problem? Well, I ran this one. I did this. I thought, well, maybe our whole approach to staircases is possibly not as good as it could be. So I ran this with the 2 staircases, but I only took out, and again, all I did was put the other staircase in up here, and I've assumed that the fire is on the top floor somewhere over here. So the top floor all has to go this way, but everyone else has a choice. Even if the door's open there and some smoke is getting out, these people won't know that. And at this stage, we're only 28 seconds into the fire here, into the evacuation. Not enough smoke is going to be getting out to
to affect them yet. It's going to take a minute or two. I mean, the fire's going to be growing, isn't it? The fire queue would have been received when the fire's relatively small, so we're not expecting huge quantities of smoke to suddenly go out into that staircase there. So this is why it's not been a problem, I think, because this is how staircases really perform in buildings. If the fire were down here, and if I'd blocked off that exit, then yes, we wouldn't have been able to get anyone out there if it had been affecting the staircase. But we wouldn't have worried about the long evacuation times up here because they're on a different floor. They're separated from it. They can wait there for 7 minutes if they want. It's only a problem if the fire is on their floor. So that's why I put the fire up there. Ignore these people going backwards and forwards. They just can't make their minds up. If we're now a minute and a half in, and I think we've got the last people going out, so we're well within our 2.5 minutes target time. These people wouldn't necessarily be doing this, but we don't know. But if the smoke were entering this staircase now, maybe coming up to 2 minutes now, maybe smoke was entering this staircase, then maybe these people might not want to stay there, and they might balk across to that staircase. Well, they can do that. They can do that relatively safely because the fire is on the top floor, isn't it? And we've got the top floor clear, which is the important thing. So this is how I think buildings probably perform more than our anticipated expectations. Got to hit that little button there. Summary. So Pathfinder here for me has shown that the assumed 2.5 minutes is unachievable when the populations are at a maximum under current assumptions. But there is no history of fire deaths. The new guidance 9999 that we have since 2008 is worse than ADB, but ADB showed pretty bad results anyway. Maybe we're too pessimistic about the performance of staircases. I'm not going to go and suggest that well, maybe I will, I don't know, that suggest that our approach to sizing of staircases has changed. There is beauty in keeping things simple, and not just beauty, the practicality, because people can understand the way we do it, and it does tend, well, it has been thought to err on the side of safety in the past. Maybe it doesn't err on the side of safety so much. All I'm trying to do, I've popularised this account in the UK to some extent, trying to just open up a debate really, and maybe the same with you. I don't know. Some of you from the UK, some from Europe, some from America, all got different codes. I don't know. I'm just saying. Think about your code. Would they work? If not, could they be better? That's all I've done. Thank you very much.
Hi. Did you look at, one thing that struck me looking at this, if you take your maximum population and your single staircase, did you look at, given the average flow of that staircase, just kind of a basic hand calculation, how long you expected, say, the worst case to leave? I mean, you could assume, worst case merging or middle case merging, and then maybe the top floor has to wait for everybody below them to get out, or a certain percentage, and you could come up with
hand calculations.
Yeah.
What hand calculations? We don't have hand calculations.
Okay.
Yeah, we have guides that tell us how big the stairs are. There are hand. I mean, there's calculations behind them.
Sure.
But they're not popularly known, and they're kind of long lost in the mists of time.
Yeah, I guess I was referring to like the SFPE handbook has some calculations for based on the width of the stair about what the flow rates would be, and you can kind of use a.
And would that cope with all the merging flows all the way down as we got?
You'd have to make some assumptions on how well you thought.
No, I didn't do any of that. Yeah. Didn't do any of that.
But just give you another data point for reference.
Yeah. No.
Where does stair pressurization come into play on this? I'm not familiar with the UK codes, but that
Yeah,
would
well,
be,
if we pressurised the stairs, then we wouldn't discount them. So this is an unpressurised, unpressurised staircases, I'm assuming. Well, they were in the building I was looking at. That could have been a possible solution for the building that we actually looked at to pressurise the staircases, yeah. But it's cheaper to put lobbies in.
As I understand it, that 2.5 minutes is sort of like a contrived number.
Yeah.
Kind of goes back in time, something to do with the length of God Save the Queen.
Don't go
or-
there. Yeah, I know it. Yeah, it's a time for that sort of room, the sort of room that you might get in an open plan office. It's the sort of time that you might expect a set to last. Typically, in a small room, it would be a lot less. Of course, and we see lots of, when you see videos of fires in offices and Scotch pine trees and things, a set is obviously about 8 seconds, in some of them, but the room is much smaller, and therefore our set would be much smaller. So it's appropriate in that sort of room.
Okay.
Anyone else?
Anything else?
Okay, thank you very much.
Thank you very much.